welcome to Algebra 1, Lesson 37. We're talking about graphing inequalities. These three symbols up here are symbols of inequality. That means that the equations they show are not equal on both of the sides. This particular symbol means is not equal to. This symbol is greater than, and this symbol is less than. I can read equations that use these symbols going in either direction. Okay, this is what I mean. Here I have 4 is not equal to 5. And I can read it from left to right, which is the way that typically we're going to read things because that's how we read. But I could also read it this way. 5 is not equal to 4. The same thing applies here. I have 4 is greater than 2. Now we have to be careful with these symbols, okay? We always read it with the side that we come to first. If the side that we come to first is open, that means it's greater than because it wants to eat the bigger number, remember? If the side that we come to is closed first, that means it's less than. It's not going to eat that, it's not open to it because it's less than, it's smaller, okay? So read from left to right, this would be 4 is greater than 2 because we came to the open end first. But read from right to left, 2 is less than 4 because we come to the closed end first. Here I have a little line underneath of my greater than symbol. This is combining the greater than with equals. And so this would be read as 4 is greater than or equal to 2 plus 2. When that happens, only one part has to be true, okay? So only the greater than or the equal to has to be true for this to be a true equation. And what satisfies this, we see that 2 plus 2 is 4, so that means the equal to part is what's true. All right? Equations can be, remember, true, false, or conditional. Let's look at this one. 4 plus 2 is less than or equal to 3. Could that be a true equation? No, because 4 plus 2 is what? Is 6. Is 6 greater than 3? Or excuse me, less than 3? No. Is it equal to 3? Again, no. So it's not a true equation. It's a false equation. This next one, x plus 2 is greater than or equal to x. Well, let's think about this. Whatever x is, if I'm adding 2 to it, that means it's going to be bigger on this side. No matter what x is, I'm making it bigger by adding 2 to it. So that means that this side is going to be bigger than this side. So it's a true equation because x plus 2 is going to be bigger than x. Here I have x is less than 4. This is a conditional equation because whether or not x is less than 4 is true is dependent on what x is. If x is negative 1, well, that's less than 4. But if x is 10, well, that's greater than 4 and would be false. So it's conditional depending on what x is. When we use a number line, we are using a number line to show really the distances between numbers. 0 is usually our starting point. It shows us like the middle of where we are. If our number is less than 0, it's in the negatives. If it's greater than 0, it's in the positives. We know that a number is bigger than another number, greater than another number, if it's to the right. If it's to the right of my number. So negative 3 and positive 2. Which one is greater? Well, 2 is to the right of negative 3. I have to go right to get to 2. So it's greater. All right, when I am working with my equations that have inequalities, sometimes they have more than one number that satisfies the equation. Remember, a number that satisfies the equation is a number that makes the equation true. For example, a number that could satisfy this equation would be negative 1. So negative 1 satisfies this. But so would negative 2, 0, 1, 3. Those all satisfy this equation. So when I have more than one number that satisfies an equation, I call that my solution set. My solution set. And I can show a solution set using a number line. So, for example, if I say graph x is greater than 2, that's going to show me all the numbers using my number line that could possibly satisfy this equation. So if x is greater than 2, I need to start out by going to the 2. Okay, there's the 2. Can x be 2? No, because 2 is not greater than 2. It's the same as. So I have to put an open circle over that spot because it cannot be 2. It starts there, but it can't be 2. And then I draw my line in this direction towards all the numbers that are bigger than 2. So I have to draw my line to the right because numbers to the right are bigger. So this is x is greater than 2. If it said, well, no, let's do the next one. Okay, so now the next equation that I have says x is less than or equal to 2. Okay, let's figure that one out. X is less than or equal to 2. Well, let's start out with 2. Could 2 be part of x? Yes, this time it can because it says that it's less than or equal to 2. So 2 can be a part of it. So this time I fill in the circle. I color it in because 2 is part of it. Now I'm looking for all of the numbers that are smaller than 2 as well. So I draw my arrow going this way. I make it an arrow because the numbers continue past my number line. So this includes all the numbers that are less than 2, as well as 2 itself. Okay, so that's how we graph our inequalities, which is what you're going to be practicing. But there's one more type of problem that you're going to be practicing with this. So let me set this up really quickly. Okay. Okay, now you're also going to have problems, exercises, where it says, write the inequality that the graph is showing. So look at what my graph has. I have an open circle over the -3 and my arrow to the left. So I'm going to start out by writing x because that's what I'm looking for. X. Now, is x part of the solution set or no? No, it's not. So I'm not going to have the line underneath because it's an open circle. All right? So my solution set starts at -3. So that's the starting number. I know that it's not equal to -3. Now, is this showing numbers that are less than -3 or numbers that are greater than -3? Since it's going to the left, it's showing numbers that are less than -3. So this is x is less than -3. Okay. Go ahead and pause now and do your practice. Okay, you should be back now from your practice. I'm going to go ahead and erase this here. Here we go. Set this up again. So we can use this for me to show you the answers to your practice. All right, your very first one says graph x is less than or equal to 5 on a number line. So we go over to 5. Here's 5. Is 5 part of my solution set? Yes, because we have the or equal to. So I need to color it in. All right, and then it says less than. So that means I need to draw an arrow to the left, showing that they are all less than. Okay, then letter B, erase that so we're not confused. Reset this here. Okay, letter B. Write the inequality indicated by this graph. So you have an open circle over the 4 and an arrow to the right. All right, so you're showing x, Your starting number is 4. You have an open circle, so it can't be equal to 4. Is it showing numbers that are greater than 4 or numbers that are less than 4? Greater than 4. So your solution is x is greater than 4. Let me know if you are having trouble with that, if you need any more help, okay? Love you guys very much, and I will see you in the next lesson. Bye.